let's talk about determinants. Okay, we're going to use these determinants to help us find the inverse of a matrix, and then that'll help us solve matrix equations. So we're going to just start off with a video here about determinants, a number that kind of represents some of the data in the matrix for us. Okay, so first off, we could write the determinant of A. That's another way to write this. Okay, and that's actually equal to, we're going to write that down a little bit different, kind of like absolute value brackets, but they're not absolute value brackets. Okay, we just use the straight bar instead of the square bracket on the outside of it, and that is supposed to tell us that it is the determinant. Okay, you don't even have to write down the determinant of, or we could also write it, we could write DET of the matrix, and that would also work. Okay, all these things mean these mean the same thing. Okay, so if this is written down, this means find the determinant of the matrix 4, -1, -2, 3, or however you want to read that. Okay, I'm a fan of basket weaving, so we're gonna try to basket weave this, which will end up being the same method we use for a 3x3 matrix in a minute. Okay, so I'm first going to draw the diagonal left to right, and I'm going to multiply those numbers. 4 times 3 is 12. Okay, I'm going to write them out here. And then anything I go left to right on, I'm going to add. So I'm actually going to just put the plus sign on there so I know that I'm adding that. And then I'm going to take the other diagonal right to left, and I'm going to subtract anything I go right to left on. So minus, and then put a parentheses, -1 times -2. Okay, and now I just have to evaluate this. So 4 times 3 is 12, minus, well, -1 times -2 is +2. So this is 12 minus 2, which is 10. So the determinant of our matrix A is 10. So the determinant of matrix A is 10. Another way to write that. Okay, let's look at a 3x3 and actually do some basket weaving here. Okay. So if I have this as my question, 6, 0, -9, 4, 3, 0, -1, 3, 0. Okay, now I want to basket weave this. Okay, what I'm going to do is I'm going to take the first 2 columns, and I'm going to rewrite them outside of the matrix. Okay, again, I'm going to rewrite or draw my diagonals left to right. I've got 3 of them this time. Okay, so all of the ones going left to right I'm going to add eventually. So 6 times 3 times 0. Okay, and I'm going to put the plus sign in front of it, plus 4 times 3 times -9, plus -1 times 0 times 0. Okay, it's going to be really nice that I had those zeros in there in just a minute. Okay, and then I also have 3 diagonals going right to left. 1, 2, 3. Okay, all of those right to left are going to be subtracted. So that first diagonal minus -1 times 3 times -9. The second diagonal minus 6 times 3 times 0. And the last diagonal minus 4 times 0 times 0. Okay, now I'm just going to cancel out anything that has a 0 in it, because 0 times anything is 0. So this goes to 0. This goes to 0. This term goes to 0. And so does this term. Okay, so I only have a couple terms left to work with here. The second term here, 4 times 3 times negative 9. Okay, so that's 12 times negative 9. 4 times 3 is 12, so that's what, 18. And 9 times 1 is 108. So negative 108. Negative 108. Gone. And then I also have negative or minus negative 1 times 3 times negative 9. Well, negative 1 times negative 9 is positive 9. 9 times 3 is 27. So this is minus positive 27. So I have negative 108 minus 27, which is going to end up being a lower negative number. Did I do that right? Yes, I did. Negative 135. Negative 135. So the determinant of this matrix, 3 by 3 matrix, is negative 135. That one's really nicely set up with all the zeros in it. Sometimes they're not so kind. You have to actually multiply out each one of those terms. Okay? So that is finding the determinants of a 2 by 2 and of a 3 by 3 matrix.